So that's not so simple, not so easy. We need to realize what are the differences between the ngOnInit and the constructor. If this is the only reason you are using ngOnInit, then it is completely unnecessary. But then you deploy on production, actually client will use it, and it will break after some minutes of using the application. Observable is just a way of delivering the value. It's just a stream of data. Instead of subscribing multiple times in our ngOnInit, we can simply define the observable properties in the component. So hello, everyone. Good evening. I would love to share you with some thoughts on how to implement ngOnInit in your components, especially in your reactive components. So while it is still a common practice to initialize quite a lot of stuff in your components, to put quite a lot of business setup in your components in this particular lifecycle hook, I think we can take all the step back and actually rethink if we really need to do this. So as Angular continues to evolve, so should our approach to implement components. We should make the components more readable, more maintainable. The components should be smaller. The setup block should be smaller and far more readable. And maybe we don't need the ngOnInit after all. So my name is Maciej. I am a senior software engineer working with Cisco. I have over 6 years of developing Angular applications, and I'm an active member of the indev.dev community, where I'm writing articles, guides, tutorials, explaining Angular very, very deeply. You can find me on Twitter. I'm always happy to talk. So by all means, if you want to talk about Angular or any web development topics, feel free to ping me there. I'm always happy to talk. So let's talk about reducing ngOnInit in our components. But first of all, let's discuss this lifecycle hook, what it really is, and the differences between this and the constructor of the component class. And then we'll move into the reactive world. We'll talk about observables, about subscriptions, and how it all connects with the reducing of the ngOnInit in our components. And lastly, at the end, we'll have 3 very useful techniques that can help us reduce the ngOnInit in our components. But even though if you are a huge fan of ngOnInit and you love to stay with this lifecycle hook in your components, then still all those 3 techniques can be still very useful for you. So bear with me. There is something for everyone. I can assure you this. So the ngOnInit is a lifecycle hook provided by Angular, and this is the moment of time when Angular has initialized all data-bound properties. So it is a useful hook. It is a useful function that we can use in the components. I'm not saying it's not useful at all. I'm just saying that we tend to overuse it. We tend to fill it with too much of initialization. We are putting too much setup code within it. And basically, I don't think this is our fault. I think we just tend to do this because ngOnInit was enabled by default when we are generating components in Angular for so long. Up until version 15 of Angular, the ngOnInit block was part of the automatic generation of the component when we were generating it from the CLI. So it was very easy for us to just use this empty function. If we needed to initialize something, if we needed to do something on start of the component, and we already had an empty function block, then it is very easy to use it, to put some stuff in this. And while it is so easy, it also allows this function to grow. And it grows rapidly. And at some point of time, the components stop being readable at all. Maintainability of this component is really, really bad. Of course, there's nothing wrong with initialization per se, but we just shouldn't overuse it. And we tend to do that. So can we maybe put all this setup code instead of the ngOnInit into the constructor, and we could be happy. I would be happy. We could make this presentation much more shorter. So that's not so simple, not so easy. We need to realize what are the differences between the ngOnInit and the constructor. So the constructor is called like very, very early when Angular creates a tree of components, precisely speaking, the tree of views. So this happens very early, and as documentation says, it should be like a really light, really easy task to do. Like Angular should be able to create component instances like immediately without any issues. At the time when the constructor is called, at the time when the component instance is actually created, we'll have the access to all the things injected by the dependency injection mechanism. So for example, all your services, pipes, etc. But we won't have access to anything DOM related because the Angular didn't render anything at this time. Angular will render your template, will render your component during the first change detection. And at the time as the first change detection happens, it will also call the ngOnInit. So this is the time when majority of things will be initialized. You will have the access to your inputs, to your outputs, maybe to some DOM elements that you need to take some measurements of, like using viewchild or any other like query decorators. So because of that, it really looks like the ngOnInit is a good case for initializing stuff because we have majority of data that we may need for like some for like further processing, further initialization. So it seems like a good candidate, but still, I think we can do better, and we can combine those two approaches, especially in reactive components. So obviously, oh, I click on something, but yeah, so let's go to the reactive world of Angular, which is obviously like quite popular. Angular uses RxJS very, very heavily. It is like a required dependency of Angular. Many things in the core of the framework uses RxJS, uses observables under the hood. If we are calling some API using HTTP client module, we are using observables. If we are transmitting some internal events, like through event emitters on outputs, or maybe by some subject in the service, we are using observables under the hood. So like we are kind of like forced to use RxJS, to use observables, but that's really good. And ngOnInit is really convenient to use for subscribing to it, right? Because if we need to read the data from the observable, we need to subscribe for this observable in order to receive the data. And in the components, when we are fetching something and we want to present something for the user as soon as possible, then like what is the best way to do it? Like obviously we need to put this in the ngOnInit because as I said, it's already there. It is empty, it's ready to be used. So we tend to do that, and then we are simply persisting the thing we fetched, the thing we resolved from the observable, persisting in the component properties. And this is like a very common use case. I'm pretty sure like majority of you have written a code like that. But I want to show you why I think this is like a quite anti-pattern and why we should avoid doing that. Oh, again, wrong. Yeah, so this is the example of this pattern that I have described. We have a data property, then we have a service injected in the constructor, and then on init we are subscribing to the observable, and once the data is resolved, we are storing this in the component class property. Very, very common practice, very common use case. But if this is the only reason you are using ngOnInit, then it is completely unnecessary, and actually it has a lot of pitfalls, a lot of issues related to this particular approach. So let's go through those issues first. The first one is with the typing. So we need to realize that actually the type of the data property is not the myData. If we'll enable the strict typing in your case configs, the compiler will throw an error because this property has no value at start. And most likely it will take some time to actually resolve it through the observable. Like if the observable is like a fetching task from the API, it can take even like a few seconds in order to initialize this variable. So for all that time, it will not be defined. So it will be undefined, and we will need to acknowledge this in our typing system. Closer? Yeah, okay, awesome. So we need to acknowledge that in our typing system. We can do this in two ways. We can use the like implicit typing, that's the type is my data, or undefined, or we can use the optional syntax. It really doesn't matter, but because after all, it will like make the optional, the property optional, which is great. It will fix our compiler issue, but what's really bad about that is the intention. Like, look what we are presenting to other components, to other developers. If I will open the component written by someone else, and I will see an optional property, I will have basically no idea what's going on, like why this property is optional. Is there maybe some business case in which the component works in two different modes, maybe like for creation and addition of some DTOs? And in one case, it can actually be undefined. In the second case, it needs to be defined. And if I need to maintain the component, if I need to change something in it, I will need to understand what's the case. Like, do I need to supply the value, or maybe I simply don't? Or maybe this is just like saying that this property is optional because we are subscribing, and we need to wait for this moment of time when the value will be fetched for us. So the intention is really, really bad. It's hard to predict what's really going on. And then even the worst thing can happen. So we can forget to unsubscribe. Every time we subscribe in our components, we really need to unsubscribe, because if we do not do that, it will cause some serious performance issues in your application. And what is really bad about that is on your local environments, when you are developing your applications, you probably won't see the problem. Everything will work fine because you're refreshing the app constantly. But then you deploy on production, actually client will use it, and it will break after some minutes of using the application. And the scary thing is there will be no indication what component caused this issue. Like, there won't be any stack trace, any error thrown in the console. You will have no idea why the app is broken. So actually tracing this issue and fixing it can be really problematic. And of course, if there is something that you need to do in every situation, in every case, at some point you will forget. Like, we are only humans, right? We can't forget something in like a stressful situation or in like a press of time. So I can guarantee at some point we will forget to unsubscribe, and it will cause some serious problems. Also, what's really bad is that the component code just doubled in size. And while the lines of code are not the most important metric, as we all know, like the mental model is. And right now, I am not able to tell like at first glance what's really going on. Like, I will need to properly analyze this component in order to get what is the responsibility, what is the function of this component. Like, there are two properties, there are two functions, there are like some nesting going on. I have no idea that the responsibility of this component is simply to fetch a single property. Like, look how many code we need to do in order to fetch a single property. This is really crazy. Like, a small hope is coming in Angular 16. This is like a new operator. It is called take until destroy. It, in many cases, can actually fetch like automatically the reference to the on destroy of the component, and it can automatically destroy, like unsubscribe for your subscription in your component. But still, you need to remember about putting this operator in every subscription in your components. So still, there's a chance that you will forget about that. And then there's a huge problem with uncertainty. We have no idea when the value will be available in our component. Like, Observable is just a way of delivering the value. It's just a stream of data. There is no guarantee when the data will be available. Like there isn't even a guarantee that the value will be available at any time. There could be an error thrown or on API, and in this case, we won't have access to our value for the whole life of the component. And this is also a very problematic issue because it can result in different behaviors on different environments, on your local machines, on your local setup with maybe some mocks instead of the backend. Everything will work smoothly. Even this silly example can work on mocks. But then once we deploy on production, there will be some timing between front-end and backend. And this thing, for sure, it will throw an error that you're accessing something from undefined. I hope it is very clear. And this is a simple example, and still I have seen this many times in the code reviews. But we can go even further. Let's imagine this last line of code is put it not on the ngOnInit, very next to the subscription block, but it is actually called in some functional click. Then are we sure that the user clicks on this button after the data is loaded? How can we be sure? Maybe we can put some ngIf or some if statement to make sure that happens. But still, we are adding boilerplate to our component, which is not really needed from business logic perspective. The data processing is not the worst thing that could happen in the subscription block, but still, it is not great because the business logic tends to grow. We are adding more things into our ngOnInit. We may even need to call a few APIs, a few endpoints to get some data. So we will end up in a few subscriptions in the ngOnInit, and each subscription will be quite long. So the whole initializing step of the component can be really hard to understand, can be really hard to fit into the mental model of this particular component. And also what's really bad about that is there's no control mechanism in TypeScript or Angular to ensure that only a subscription block can mutate, can assign this value. We are not sure that there is some other function called onClick on maybe some other subscription that can affect this value, that can mutate it. That could happen. That could happen. So if we really need to analyze what's going on, we'll need to read carefully through all lines of this component. And this is not great if we need to maintain it, if we need to simply add some silly, small feature into it. This is really bad, and the mental model grows. And lastly, there is some nesting. So quite often, we need to subscribe for something, and then once we get the data, we are subscribing even more for something else based on the data from the previous subscription, and can go on and can go on. We can have multiple levels of nesting. And now, understanding when the value will be actually to be used, when it will be resolved, it is very, very hard. Even remembering what the things that needs to happen before, what they are, fitting this into our mental model of the component is really, really hard. So of course, this example is rather simple. We have only 2 subscriptions, but it is a quite often situation that we have 5 or 6 levels of nesting, and the whole thing becomes really, really unreadable. So what I think about all of this is, instead of taking the full advantage of the observables, of the whole beauty of the reactive world that we have in Angular, we are staying in this comfort zone of subscribing as soon as possible for our values. And when we are storing the values as the component properties, we are feeling kind of safe. As we have the values, we store them, and now we are kind of feeling safe that we can operate on them, we can use them in the templates, we can do basically whatever we want, because we avoided this problem of having asynchronous data. But we really didn't. Like, I have showed you all those issues related to subscription for something. It's like really unpredictable, and we are making a lot of mistakes when combining this asynchronous and synchronous code in our component. What I would like to present is like a design of treating components more like a functions to render something. Like, this should be the purpose of the component, to render something for the user on the screen. Instead, we are very frequently treating components as a kind of databases, like a front-end instances of the databases. We are storing quite a lot of things in the component, which is not really for that. Like, the component should be really for rendering stuff. And that's the only thing that should happen. So as you can tell, this design is like quite important for me as a concept, but it also resolves all sources of the issues that I have presented before. So this is basically the approach. Instead of subscribing multiple times in our ngOnInit, we can simply define the observable properties in the component, like simply as that. And then we can use these observable properties in the template. There's no need for subscribing for it. There's no need for storing the values. Like, there's no need even for like storing it twice. We can have like a single source of truth, which will be our service or our observable. The component doesn't really need to store it twice. We can use it with async pipe. And the async pipe is something built in Angular, so you don't need any external library or something. It is pretty efficient. So you can actually resolve any asynchronous values like observables or promises using the async pipe. And then in the template, you always have the last emitted value from those asynchronous source of data. So this is really simple. And now we'll go through all those issues and check if they still exist or maybe not. So first of all, the typing. As you can see, we are declaring the observable property like on start on the component creation. So there is no way that this observable, this reference to observable, will not have a value. It has a value from the very start, from the very construction of the component class. Not even that, we can add the read-only keyword because we don't want anyone to mutate it, to change this property. Like, it is a complete set of data ready to be used. And this is really good in case of the intention that we are leaving for other developers. Like, we are clearly saying that this property is complete, is ready to be used. You probably don't need to do anything with this property, just simply use it in the template. Next, there is no problem with the unsubscription, with unsubscribing from the subscription, because async pipe does all those things for us. We don't need to put any boilerplate into our component classes. And this is really great because we don't need to remember about that. But also, our component code stays 100% focused on the actual business logic. There is no need for adding something to avoid memory leaks, to avoid some problems. Everything that we are doing in the component is really the responsibility, is really the purpose of this particular class. And it was really clean and readable approach. And then we were talking about this uncertainty regarding when the value will come, when we'll have access to it in order to maybe process it or maybe take some fragment of the response. So we need to start thinking reactively. Like, observables are the most powerful when we are treating them as a streams of data and not resolving as soon as possible. Like, if we are treating observables like a streams of data, we can do whatever we want with those streams. We can combine them, we can process the values, we can even like apply some rules over those streams to adjust them to our needs, to the purpose of the component. And applying those rules on the reactive streams, it is really easy. Like, we have a pipe, which is like a wrapper for all pipeable operators, and each pipeable operator can somehow transform our stream of data. We can apply any data processing that we would normally do, but in a way of applying the rules on the stream. We are not modifying the values. We don't really care when or if the value will arrive. We are simply saying that when the value will arrive, just please apply those rules. Please do this processing. It is simply about defining some rules and not actually making them on the actually resolved values. And by that, we are ensuring that every time the result from the observable will be up to date, will be fresh, and we don't need to like store it or like restore it every time that something changes. And yeah, so with the data processing, it is really like pretty much the same. We can still apply in the same operator. So we can use the map operator, which is a pipeable operator that simply transforms the values that comes through the observable. And what is really great is I have told you that before there was no mechanism, no controlling mechanism that someone else is not modifying our value. In the map operator, in the observables, we are sure that only the things within the pipe wrapper can actually affect the values. Like there's no way that like some other function or like even some other component can affect this observable. It is like complete within this pipe operator, within this pipe wrapper with all those pipeable operators within it. So if we need to understand why this particular observable has some bugs, like maybe something is missing, we only need to read through this single pipe wrapper, which is really, really good. And the pipeable operators can also help us with nesting. So with nesting, we need to think about that more like mapping observable into observable, maybe into another observable. So in this process, we can create like an observables of observables of observables. And this is actually like quite hard to resolve, like because we are generating a lot of observables, which we would need to subscribe for it. So that's why we have the flattening operators, which like in a single run, they map and they flatten the structure of the observables. So we don't have the observable of observables. We'll always have a single observable with only like a plain value. So these flattening operators are, for example, the switch map, the merge map, concat map, exhaust map. They all differ in a way of handling the value when the new value arrives, but basically they all do pretty much the same thing. Depends on your use case. You may need to use different one. In here, I'm using the switch map because I only care about lastly emitted ID. So yeah, all those things hopefully looks all right to you, but then you might start wondering if this is really all right that I am putting so much like potentially heavy computations inside those observables defined at start. Like previously, I've said that the construction time, the constructor should be very light. There should not be like much processing inside of it. So is it really all right to put all those things in the pipeable operators? And for that, I think I think we need to realize what is the difference between the promise and the observable. So unlike promises, observables won't be called until they are subscribed. And this is really important for this particular concept, because as you see, we are subscribing with the async pipe. And the async pipe is prepared for us in the template. And as I said, the template won't be rendered at the construction. It will be rendered during the first change detection. So at the time when the ngOnInit is called. So in the same time that the ngOnInit is called, our async pipe will arrive, it will subscribe, and it will actually run the whole observable. So all those potentially heavy computations that we have in the map operators or some other operators within the pipe wrapper, all those things will run basically at the time of the ngOnInit. So all those things that I have prepared for you, they're basically like a reactive version of the ngOnInit. They will happen in the time of ngOnInit, but they don't really need to implement ngOnInit at all and store any properties. And now let's take a look at 3 techniques that can help you limit number of observables, that can help you reduce the ngOnInit even more. So this particular one, it is called the view model, and it is really the technique to limit number of observables, limit number of subscriptions in your components. So even if we are using all like appropriate operators, we are doing everything that I have presented to you, we still can end up in a situation that we have a lot of observables or maybe a lot of async pipe in the template. Like we may even need to like resolve the same observable multiple times in the template because we need the data in a few DOM elements. So for that, we are putting like quite a lot async pipe in the template, which cannot be like ideal situation because each async pipe will trigger change detection on emit from the observable. So if we'll end up with like quite a lot async pipes in our template, it can cause some performance issues. So we need to tackle that. And there are some libraries that tackles that problem, for example, by implementing their own versions of the of the async pipe. And like that's all good, you can use it. But still, I would like to show you like a technique to limit the number of async pipes in your template without really a need for any external library whatsoever. And yeah, for that, we can use the view model approach, which is like an approach to create like a complete set of data that will be used for render in the component. And this is really intuitive for me because if the purpose of the component is to render something for the user, then like what's like the better way than putting all those things that will need to be rendered inside a single block, inside a single object. Obviously, with like a regular components, it is so much easier to wrap all those properties inside a single property, inside a single object. With our reactive components, we need to do something more because we have observables. We can't simply combine them. We need to create another observable that is created based on those like source observables. And for that, we can use the combine latest operator, which basically creates a single observable that on every emit will have an object, and this object will have 2 properties that will have always the lastly emitted values from those sources observables. So that's the approach. And as you can see, it is like fairly easy to use it in the template. So Konrad was saying like, how can we use the ngContainer for content projection? In here, we can use the ngContainer as a fake DOM element that won't be added to the DOM at the runtime, but we can use it to like help us structure our template. So we can use it to put the ngIf, we can use to resolve the view model with a single async pipe, no matter how many observables like initially we had. Now we have a single async pipe, we're resolving this whole observable only one, and then we can use it as this component, as this template property, VM, everywhere in our template. It is really readable. It is really easy when I need to maintain a component and something is not right in the template. I know what the property of the component I will need to look for because there's only a single one. And there is a second great thing about this approach. Is basically sometimes you may feel that this view model concept in your component doesn't really fit. Maybe you feel like the data semantically doesn't fit, or maybe the timing is not right because like one property is resolved very like soon, and then the second one may be on some user interaction, and you may feel that the view model is not for you. But this can actually mean that the component has too much responsibility, and maybe it doesn't fit semantically in the component. And maybe it even makes more sense to split the components into multiple ones, and then the view model can be applied without any issues. The second technique is the selectors. And this is a very powerful feature from the NgRX, which is a state management library. Of course, I won't talk about the state management here. It could be like another topic for another meetup. But basically, it is a very powerful feature which we can use to simplify our components even more. So if we are using the state management from ngRX and we want to read something from the state, we are using selectors, which are like a pure functions, really, really simple, that read something from the state. We can create selectors using other selectors, like combine them together, which is actually really great in case of the performance. And we can outsource everything that we had in those pipeable operators back into the selectors, which is really great because when we are outsourcing the logic from the component, we are making component like smaller, easier to understand. And in the other hand, the business logic is easier to reuse and it is easier to test because we only need to test like a simple, pure function. And in the component, it is really easy to use the selectors. We are simply having a single observable property that reads something from the state. And the component code is really, really simple. No need for ngOnInit, really readable solution. And the last thing is the component store. It is a very small, very tiny package, also from ngRX, but you don't need to use ngRX as your like state management library. You don't need to have the state management at all. You still can use the component store. I really encourage to do so. It creates like another layer for the component to provide a data. And this really combines everything that we have learned today so far. So the component store can expose a single view model instance, which would be like an observable, ready and complete for use in the component, which we'll, of course, use in the template, resolving it using the async pipe. And the component store can prepare this view model using selectors, using other observables, using local state. It can still use all pipeable operators that we have learned today. So basically, it combines everything. It exposes a single instance of the view model to the component. And the component really stays within this like single responsibility of rendering things and not having to initialize some setup code, which is not really needed. So yeah, that's all. Thank you so much. Thank you for having me. Like my final thought is to start treating components as a functions to render data, as a functions to project something for the user, and not treating components as a databases and storing everything in their classes. So that's all. And now I think it's a great moment for questions. The question basically is, we need to download something that depends on the inputs of the component. Okay, then still this approach works because, as I said, when we are creating the observable and we are defining them as a component properties, they won't be run, they won't be subscribed until they are until the template is rendered. So we'll have access to all inputs, outputs, and we can create the observable, we can initiate the observable based on the input value. So there is a question about how is error handling done. So basically, you can deal with the error handlings like however you want. You can catch error and display something else in the template. You may use the materialize operator to basically combine all three streams in the observable into a single stream. Basically, once we have the observable, we can do whatever we want, especially error handling. Okay, no more questions from the chat. Okay, then I think we are good. Thank you.